Hello again. Still talking about equations in this video, guys, but we're talking about models this time. And we have a few pictures, and there's me blocking the camera again. Terrible of me to do that. And we're talking about pictures basically that are going to convey the message of an equation and allow us to not only write it as an equation, but hopefully to solve it as well. These are one-step equations. Two-step equations we'll do sometime in the future, whether in class or out of class. And I wanted to draw some very simple balance problems for you. This, in fact, is a balance. It is not the Starship Enterprise, although it does look fairly similar. And one thing that you will always see when you're talking about a model, whether it's a balance model or it's something else, you're going to have some sort of understanding of what the symbols mean in a model situation. So for that, you're always going to see a key. So you'll always see a key for something, because you don't know what the squares mean, the circles mean, unless you have something to clue you into that. And for the other question on the bottom, you'll also have a key as well. And so anytime you make your own models, anytime you solve your own models, either look for or create a key, because you want to have that level of understanding so people can actually see what you're doing. So the first example we have right here, we have a key of every square is a y and every circle is a 1 or a positive 1. Sometimes the class will use like chips, colored chips or counters, maybe even use cereal. I like to use Apple Jacks and use green Apple Jacks as positive counters and red ones as negatives. And we use a lot of that in the integers course, part of the course as well. So be ready for that. And if we haven't gotten there yet, if we have gotten there, then there you go, nice little review. So as we take a look at this model, let's translate it. Let's actually take it from the picture and make it into an equation, and if we can solve it, we'll solve it. It looks as though on the left side of the equation, because we have a left side and a right side separated by an equal sign, just the way that I like to write my balances, we have a y, oops, a little bit wobbly there. We have a y, because that's a square. So I have a y there, and it looks like on the same side I have 1, 2, 3, 4, 5 circles. And since I have 5 circles, I'm going to put a 5 there, but that doesn't look quite right because there's no math operator there. I don't think it's going to be subtraction because I don't see anything that involves negative numbers. I don't see anything that would involve dividing things up. I'm not splitting anything up. I'm not multiplying anything because I don't see anything just spontaneously getting bigger. I just see what I see on the balance on the left side. And so the only thing that's left over is to think about, well, if this is a combination of items, I have a square and I have a bunch of circles, then if I'm combining it in a group, wouldn't that just be addition? So I'm going to call it addition. So I have y plus 5. Pretty easy, right? So I have y and 5. I have a square and some circles. And it's usually a word that means math, and I call it addition. If I look on the other side, I have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so I'll just place a 9 there. Pretty easy, right? I could solve that probably in my head. Matter of fact, you have solved these in your head before because algebra is something that you've been talking about probably since you were about 1st grade. You just didn't know it. The opposite operation of adding 5 is subtracting 5. So I'm going to do just that. And I'll let you tell me the answer. I'm not telling you the answer. You tell me in class. If we look at the next example there, we have 1, 2, 3, 4 boxes, so that's 4 y's. Now, I'm not going to write y plus 4. That would be like this, similar to this. But I have 4 y's. So I would literally write that as 4 y's. I have 4 y's. So I actually have a coefficient in this particular equation once it's written fully. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I have 12 counters on the right side. So I would have the equation 4y equals 12. So I have a coefficient here. I want to get rid of that coefficient. We always say that between the coefficient and the variable that I have a multiplication symbol. It's invisible. It's not always there. But we know it's there. It's understood to be there. And so the opposite of the opposite of multiplication is division. So to get rid of that 4, I have to divide. And 12 divided by 4 is, I'm leaving it blank. You figured out. You tell me in class. I'd like to know what you're thinking. I'd like to know you're taking notes. We have an example on the bottom of the board that I'll let you try yourself. You have a key. Each star is an x, so that's an x variable, not an x multiplication sign. And you have a triangle, which is a single counter, or a positive 1 if you want to call it that. And it looks like you have 5 stars equals, looks like 20 triangles. So I'll ask you to translate that, and I'll ask you to solve it as well. And I'll ask you to bring that solution in that equation to class.
Ms. Riddick, would you report to the main office? Ms. Riddick, please report to the main office.
And as long as Ms. Riddick reports to the office, we can take a look at the vocab here. And this is the same vocab as before, folks. It's from 6.18. This is the equations unit. And although these are not full textbook and dictionary definitions, it's a nice little review of most of those concepts that we are talking about or have talked about in class, and some examples as well, what to look for. Are we looking for an equation having an equal sign? Yes. Are we looking for an expression not having an equal sign? Yes. Coefficients are always numbers that are paired up with a variable. Variables are unknown numbers. Terms are actual letters or numbers that are separated by mathematical units or equal signs. And we have algebra, and that's just kind of a rough definition of algebra, of it being related to balance. Whatever I do on one side of an equation, and by that I mean whatever I do on one side of an equal sign, I must do to the other side in order to preserve the value of the problem and to balance things properly. And that's about it for this this unit. Maybe more videos will be made in the future, but I think this is good for now. And I look forward to talking to you guys in class about this. Make sure you take your notes, make comments, be well.